What if I told you that right now, at this very moment, something is hurtling toward our solar system at speeds that shouldn't be possible, and 3 weeks ago, it spoke to us? I'm not talking about a satellite malfunction. I'm not talking about some conspiracy theory. I'm talking about documented, peer-reviewed data from multiple observatories across 4 continents that have picked up something that has turned everything we thought we knew about comets completely upside down. The object is called 3I Atlas. The I stands for interstellar. This thing didn't originate in our solar system. It came from somewhere else, somewhere impossibly far away. And on October 23, 2025, radio telescopes at the Arecibo Successor Array in Puerto Rico detected something that made the lead astronomer, Dr. Maria Vasquez, literally drop her coffee mug on the laboratory floor. A signal, a repeating, structured radio emission coming directly from the comet itself. Not reflected, not ambient cosmic noise. A signal originating from the comet, cycling every 47 minutes with mathematical precision that natural processes simply cannot produce. Here's what will blow your mind. This isn't some distant phenomenon we're passively observing. 3I Atlas will make its closest approach to Earth in exactly 127 days. And whatever is creating that signal, it's getting stronger. But before you think you know where this is going, let me stop you right there. Because what we're about to explore together over the next 3 hours will challenge every assumption you have about what's possible in our universe, about the nature of intelligence itself, and about humanity's place in a cosmos that may be far stranger and more alive than we ever imagined. If you're ready to have your mind completely rewired, smash that like button right now. Subscribe and hit the notification bell, because this story is developing in real time, and I'll be updating you as new information emerges. And I want to know, drop a comment telling me which country you're watching from, and what time it is, where you are right now. Let's see how global this moment really is. Now, let's start from the beginning. To understand why 3I Atlas is so revolutionary, you first need to understand just how mind-bogglingly rare interstellar objects actually are. Think of it like this. Imagine our entire solar system is a single house on a street. The nearest neighboring house, the nearest star system, is 25 million miles away. That's the equivalent of a house on a street where your neighbor lives across an entire continent. Space isn't just big. It's incomprehensibly, horrifyingly empty. For billions of years, we assumed our solar system was essentially closed. Sure, stuff moved around inside it, asteroids, comets, planets in their orbits, but nothing came in from outside, and nothing went out into interstellar space. Our solar system was an island. Then, on October 19, 2017, everything changed. Dr. Robert Warwick, an astronomer at the University of Hawaii, was reviewing routine telescope data from the Pan-STARRS survey when he noticed something impossible. An object moving through our solar system at a velocity that couldn't be explained by any gravitational interaction with the sun. It was moving too fast. And its trajectory was all wrong. It was on a hyperbolic orbit, meaning it came from outside our solar system and would eventually leave, never to return. They named it Oumuamua, which means scout or messenger in Hawaiian. Oumuamua was the first confirmed interstellar object ever detected passing through our solar system. Think about that. In all of human history, across thousands of years of watching the skies, we had never definitively proven that objects from other star systems could visit ours. And suddenly, there it was. But Oumuamua was weird. Really weird. It was shaped long and cigar-like, with a 10-to-1 length-to-width ratio that we've never seen in any natural solar system object. It tumbled through space in a complex rotation that suggested it wasn't a simple ball of ice or rock. And here's where it gets truly bizarre. As Oumuamua moved away from the sun, it accelerated slightly in a way that couldn't be explained by solar radiation pressure alone. Dr. Avi Loeb, chair of Harvard's astronomy department, published a controversial paper in 2018 suggesting that Oumuamua's anomalous acceleration could be explained if it were actually a light sail of thin, artificial structure designed to be pushed by starlight. The scientific community largely rejected this hypothesis, preferring explanations involving exotic outgassing of frozen nitrogen or hydrogen. But the debate never really ended. We simply didn't get enough data before Oumuamua disappeared back into interstellar space. 2 years later, in August 2019, amateur astronomer Gennady Borisov discovered the second confirmed interstellar object using his own homemade telescope in Crimea. They named it 2I Borisov, the 2I indicating the second interstellar object. Unlike Oumuamua, Borisov looked and behaved like a normal comet. It had a tail. It outgassed carbon monoxide and water. It had a typical comet shape. Scientists breathed a collective sigh of relief. See? They said, interstellar objects are just comets and asteroids from other star systems. Nothing weird going on. 2I Borisov was comfortable. It was explainable. It fit our models. And then came 3I Atlas, discovered on March 2, 2025, by the Atlas Survey System in Hawaii, the same system that has discovered dozens of near-Earth asteroids. 3I Atlas initially seemed similar to Borisov. Spectroscopic analysis showed water ice, carbon dioxide, and organic compounds, all normal comet stuff. It had a coma the fuzzy cloud of gas and dust that surrounds a comet's nucleus. Its trajectory confirmed it originated from outside our solar system, probably from somewhere in the direction of the constellation Hercules. Everything was normal, textbook interstellar comet, until October 23, 2025. Here's what will blow your mind. The signal didn't start as the comet got closer to us. It started precisely when the comet crossed an invisible boundary in space, the heliopause, the region where the sun's solar wind meets interstellar space, about 11 billion miles from the sun. The exact moment 3I Atlas entered our solar system's sphere of influence, it turned on, like something waking up. But I'm getting ahead of myself. To understand what happened next, you need to understand something most people don't know about comets. They're not just dirty snowballs. They're time capsules. Pristine samples of the materials that existed when our solar system, or in this case, another star system first, formed 4.6 billion years ago, which means 3I Atlas is older than Earth, older than the Sun. It carries within it the frozen chemistry of another world, another star, another corner of the galaxy that may be radically different from our own. And now, Pet Ancient Visitor is talking. Let's talk about what exactly Dr. Maria Vasquez and her team detected. The Arecibo successor array built to replace the famous Arecibo radio telescope that collapsed in 2020 is one of the most sensitive radio detection systems on Earth. It was performing a routine sweep of the southern sky on October 23rd when it locked onto 3I Atlas for a standard observational pass. Radio telescopes point at comets all the time. We use them to study the molecules in cometary comas, to measure outgassing rates, to map magnetic fields. It's routine science. But at 3:47 a.m. Atlantic Standard Time, the detection software flagged an anomaly. The comet was emitting radio waves at a frequency of 1420 megahertz. If you're not an astronomer, that number might mean nothing to you. But to anyone who studies CT, the search for extraterrestrial intelligence, 1420 megahertz makes your blood run cold. Think of it like this. Imagine you're trying to communicate with someone across a crowded, noisy stadium. You can't just yell random sounds and hope they hear you. You need to pick a frequency, a channel, that both of you would naturally think to use. In radio communication across the universe, 1420 megahertz is that natural channel. It's called the hydrogen line, the frequency at which neutral hydrogen atoms naturally emit radiation. Hydrogen is the most abundant element in the universe. Every civilization that develops radio astronomy will inevitably discover the hydrogen line. It's the universal "you are here" marker in the electromagnetic spectrum. Since the 1960s, SETI researchers have prioritized listening at 1420 megahertz precisely because any technological civilization trying to get our attention would logically broadcast there. 3i Atlas was broadcasting on the hydrogen line. Dr. Vasquez's first assumption was equipment malfunction. But when she called the Very Large Array in New Mexico and asked them to point their dishes at 3i Atlas, they confirmed it within 20 minutes. Then the Parkes Observatory in Australia. Then the Meerkat Array in South Africa. All confirmed. All detecting the same signal. But here's where it gets truly bizarre. The signal wasn't constant. It pulsed with a precise 47-minute cycle. And within each cycle, there were substructures bursts of varying intensity that repeated in patterns that Dr. James Chun, a mathematician at MIT specializing in pattern recognition, described as statistically impossible to occur naturally. What if I told you that when Chun's team ran the signal through algorithmic analysis, they found nested periodicity, patterns within patterns? The 47-minute cycle contained 16 distinct pulse sequences. Each sequence contained between 7 and 13 individual pulses, and the intervals between pulses formed ratios, simple mathematical ratios like 2 to 3, 3 to 4, 5 to 7. Prime numbers, Fibonacci sequences, mathematical constants. Natural processes don't do that. Natural radio emissions from astronomical objects, pulsars, magnetars, even lightning on Jupiter, produce noise, or at best simple periodic signals. They don't encode mathematical relationships. Think of it like the difference between a dripping faucet and Morse code. Both make repetitive sounds. But one is random, caused by water pressure and gravity. The other is structured, intentional, designed to convey information. The 3i Atlas signal is Morse code from space. Dr. Vasquez immediately contacted the International Astronomical Union and filed a report with NASA's Unexplained Aerial Phenomena Task Force. Yes, the UAP office that used to focus on reports from Navy pilots now also coordinates responses to anomalous signals from space. Within 48 hours, a classified briefing was held at the White House. Within a week, every major radio telescope on Earth had redirected observation time to study 3i Atlas. The signal has been broadcasting continuously ever since. Here's what will blow your mind. The signal is getting more complex. In the first week of detection, there were 16 pulse sequences per cycle. As of November 10th, there are 23. The signal is evolving, changing. It's not a simple beacon repeating the same message. It's adapting. And the adaptive changes began precisely when Earth-based telescopes started actively observing it. It's like 3i Atlas knows we're listening. Now, before you jump to the obvious conclusion that this must be an alien spacecraft or probe, I need you to understand something critical. That explanation, as wild as it sounds, might actually be one of the less radical possibilities. Because what if the comet itself is alive? Stay with me here, because this is where most people's mental models of biology break down completely. When you think of life, you probably think of cells, DNA, metabolism, reproduction. Life is warm, wet, carbon-based chemistry happening at room temperature on planets with atmospheres and liquid water. But what if that's just parochial thinking? What if life, real, complex, information processing life, can exist in forms we never imagined? Dr. Claudia Morrison, an astrobiologist at Caltech, has spent the last 15 years studying extremophiles organisms that survive in conditions we previously thought were completely incompatible with life. Bacteria that live in boiling acid. Microbes that thrive in the radioactive cores of nuclear reactors. Organisms that remain viable after being frozen for hundreds of thousands of years in Antarctic ice. The more we study extremophiles, the more we realize that life isn't fragile. Life is astonishingly, terrifyingly resilient. In 2023, Morrison's team published a paper proposing that comets, not planets, might actually be the ideal environment for preserving and transporting complex organic chemistry across interstellar distances. Think of it like this. Planets are violent places. Atmospheres erode. Tectonic activity reshapes surfaces. Asteroid impacts sterilize entire hemispheres. Life on planets has to constantly fight against entropy. But comets? Comets are frozen in time. They spend millions of years in the cold, dark outer regions of star systems where nothing changes. Organic molecules remain pristine, locked in ice. And comets get ejected from their home systems all the time. Gravitational interactions with giant planets can fling them into interstellar space. Once a comet is traveling through the void between stars, it becomes a perfect preservation chamber. Radiation levels are low. Temperatures hover just a few degrees above absolute zero. Any complex chemistry inside the comet essentially goes into stasis until it encounters another star system. This is the theory of panspermia, the idea that life might spread between star systems via natural processes, hitchhiking on asteroids, and comets rather than evolving independently on every planet. But Morrison's hypothesis goes further. She proposes that the organic chemistry inside comets isn't just passively preserved. Under certain conditions, it might actually be processing information. Here's what will blow your mind. In 2024, researchers at the University of Copenhagen demonstrated that complex organic molecules in frozen water ice can undergo photochemical reactions when exposed to cosmic rays. These reactions can create what they called cryochemical networks, self-organizing chemical systems that respond to environmental stimuli. It's not life as we understand it. There's no DNA, no cells, no reproduction in the conventional sense. But it is a chemical system that processes information and changes its state in response to inputs. Imagine a computer made not of silicon chips, but of frozen organic molecules. Instead of electricity, it runs on cosmic rays and photons from distant stars. It processes information not in nanoseconds, but over millions of years. And instead of being designed by engineers, it emerged spontaneously from the chemistry of the early universe. That's what might exist inside 3I Atlas. When the comet crossed into our solar system and began receiving higher levels of solar radiation, the cryochemical networks inside could have activated transitioning from dormancy to active information processing. And if those networks are complex enough, they might be capable of generating structured radio emissions. Not intentionally, not with consciousness or purpose in the way we understand it, but as an emergent property of their information processing activity. Think of it like this. Your brain generates electromagnetic fields as a byproduct of neurons firing. You're not trying to broadcast radio waves, but if someone had sensitive enough equipment, they could detect the electromagnetic signature of your thoughts. The structure of that electromagnetic field would reflect the structure of your neural activity. What if the signal from 3I Atlas is the electromagnetic byproduct of ancient alien chemistry waking up? Dr. Morrison is currently leading an international team trying to model this hypothesis mathematically. Her preliminary simulations suggest that cryochemical networks, if sufficiently complex and if exposed to the right kind of radiation environment, could indeed produce structured radio emissions with the characteristics we're observing from 3I Atlas. But here's the kicker, and this is the part that keeps Morrison awake at night. If this hypothesis is correct, then 3I Atlas isn't unique. There could be millions of comets drifting through interstellar space, carrying dormant cryochemical networks, waiting to activate when they encounter a star system. The galaxy might be full of thinking comets. A vast, distributed intelligence spread across billions of frozen objects, each one a node in a network that spans hundreds of light years and operates on timescales of millions of years. And we just started listening to one of them. Now, does that mean 3I Atlas is alive? That's a philosophical question as much as a scientific one. It processes information. It responds to its environment. Its internal state changes over time in complex, structured ways. By some definitions, that's life. But whether or not we call it life, one thing is undeniable. Something inside that comet is computing. Something is processing information at a level of complexity that produces mathematically structured radio emissions. And that something came from another star system, carrying within it the chemistry and perhaps the information patterns of an alien origin. Which brings us to the question nobody wants to ask out loud, but everyone is thinking, what is it computing? What information is encoded in those pulses? And why is the signal getting more complex the longer we observe it? Before we go further, I want you to pause and really think about what I just told you. We have detected a mathematically structured radio signal coming from an object that originated in another star system. That signal is evolving. It's becoming more complex, specifically after we started observing it. If you're not feeling a chill down your spine right now, you're not paying attention. Drop a comment and tell me, do you think this is natural chemistry, or are we witnessing something deliberately trying to communicate? I genuinely want to know what you think. Now, let's talk about the attempts to decode the signal. When SETI researchers talk about decoding potential alien messages, they usually reference something called the Arecibo message radio transmission sent toward the M13 star cluster in 1974. That message was carefully designed to be decodable by any technological civilization. It contained information about human biology, our solar system, and the structure of DNA, all encoded in a simple binary format that, when arranged properly, creates a visual image. The logic was straightforward. Any civilization smart enough to detect the message would be smart enough to try arranging the binary data into rectangular grids of various dimensions. Eventually, they'd stumble on the correct arrangement and see the image. But the 3i Atlas signal isn't like that. It's not binary. It's analog continuous variations in signal intensity rather than simple on-off pulses. And it doesn't obviously map to any visual format. So how do you decode something when you don't even know if it's a message or what format it might be in? Dr. Kenji Tanaka, a cryptographer and information theorist at Tokyo University, has been leading the primary decoding effort. His approach is based on looking for mathematical invariance properties of the signal that remain constant, even as the surface structure changes. Think of it like this. Imagine someone is speaking to you in a language you don't understand. You can't decode the meaning of individual words, but you can analyze statistical properties of the speech. How often do certain sounds repeat? What's the distribution of syllable lengths? Are there recurring patterns that suggest grammatical structure? Even without understanding the language, you can learn something about its structure. Tanaka's team applied similar analysis to the 3i Atlas signal, and what they found is extraordinary. The signal has what's called high algorithmic complexity. That means it's neither random noise nor a simple repeating pattern. It contains structure, but that structure is rich and varied, similar to the complexity you'd find in human language, in music, or in compressed data files. Here's what will blow your mind. When Tanaka calculated the entropy, essentially, the information density of the signal, he found it was remarkably close to the theoretical maximum for a continuous analog transmission. That means the signal is information-rich. Almost every variation in pulse timing and intensity carries meaningful information, rather than being redundant or noise. It's like the difference between he-ho, a-you-you versus hey, how are you? Both convey the same basic meaning, but the second is maximally efficient, no unnecessary repetition or stretching out. The 3i Atlas signal is maximally efficient. Whatever it's encoding, it's packing in as much information as physically possible. But what information? One breakthrough came from Dr. Lisa Huang, a physicist at CERN specializing in high-energy particle physics. She noticed that some of the numerical ratios in the signal pulse timings matched ratios she'd seen before in particle physics. Specifically, the mass ratios of fundamental particles. Think of it like this. An electron has a certain mass. A proton has a different mass. A neutron has yet another mass. These masses aren't arbitrary. They're fundamental constants of our universe, determined by the properties of quantum fields and the Higgs mechanism. And here's the thing. Those mass ratios are universal. An electron in another galaxy has exactly the same mass as an electron here. The ratio between an electron's mass and a proton's mass is the same everywhere in the universe. If you wanted to create a universal calibration signal, a message that any technological civilization could decode because it references universal constants encoding particle mass ratios, would be a brilliant approach. Huang's analysis suggests that approximately 30% of the signal structure can be interpreted as references to fundamental physical constants: the mass of an electron, the fine structure constant, the speed of light, Planck's constant. It's like the signal is saying, here's a physics textbook. Let me show you what numbers I'm working with so you can understand the rest. But that still leaves 70% of the signal unexplained. And that 70% is where things get truly weird. Dr. Patricia Blackwell, a neuroscientist at Oxford, who usually studies brain signals in humans, was brought into the decoding effort because of her expertise in analyzing complex biological rhythms. She noticed something that everyone else had missed. The unexplained 70% of the signal has temporal patterns similar to neural oscillations. Your brain doesn't just fire neurons randomly. It generates rhythms, theta waves, alpha waves, gamma waves, electrical oscillations at different frequencies that coordinate activity across different brain regions. These rhythms are how your brain synchronizes information processing, how different parts of your brain talk to each other. Blackwell found that the 3I Atlas signal contains nested oscillations at multiple timescales, with phase relationships between them that mirror the phase relationships found in mammalian brain activity. It's like listening to a brain thinking. Now, this doesn't mean the comet has a brain. It doesn't mean there's consciousness inside 3I Atlas. But it does suggest that whatever system is generating the signal operates according to principles similar to neural information processing. Remember the cryochemical network hypothesis from earlier? If frozen organic chemistry is processing information inside the comet, it makes sense that it might use oscillatory dynamics similar to biological neural networks. Oscillations are an efficient way to coordinate activity across spatially distributed systems. But here's where everyone involved in the decoding effort starts getting nervous. The signal structure is changing in response to Earth's transmissions. Yes, we started transmitting back. On November 1st, NASA authorized a response transmission from the Goldstone Deep Space Network, a simple, structured radio pulse sequence designed to indicate intelligent reception. Basically, we sent back a mathematical pattern to say, we hear you. We understand this is structured. Here's a structured pattern from us. 71 minutes later, the light travel time for radio waves to reach 3I Atlas and return, the comet's signal changed. New pulse sequences appeared. The mathematical ratios shifted subtly but unmistakably. And some of those new patterns directly mirrored elements of the transmission we sent. 3I Atlas echoed us. And then it elaborated on what we sent, adding complexity, extending the mathematical patterns we initiated. It's responding. It's engaging in what can only be described as a dialogue, which means one of two things. Either we're witnessing the most elaborate natural coincidence in the history of science, or something inside that comet is paying attention. Let's step back and ask the obvious question. Where did 3I Atlas come from? When astronomers track the trajectory of an interstellar object backward, they can calculate its origin point, the region of space it came from. For Oumuamua, that was near the star Vega. for 2I Borisov, somewhere in the direction of Cassiopeia, though no specific star could be identified. For 3I Atlas, the answer is both more specific and more disturbing. Dr. Samuel Wright, an astronomer at the University of Arizona, specializing in stellar dynamics, spent 3 weeks computing high-precision backward orbital integrations for 3I Atlas. This is insanely complicated. Math you have to account for the gravitational influence of every star the comet passed near during its journey, correct for galactic rotation, factor in uncertainties in the comet's velocity and position. But Wright's calculations converge on a single origin point, HD 104,985, a giant star in the constellation Ursa Major, approximately 330 light-years from Earth. HD 104,985 is not a normal star. It's an evolved giant star that has exhausted the hydrogen in its core and expanded to many times its original size. In another few million years, it will shed its outer layers entirely and become a white dwarf. But here's what makes it relevant. In 2003, astronomers confirmed that HD 104,985 has at least one planet, a Jupiter-sized world orbiting at a distance similar to Jupiter's orbit around our Sun. And when a star evolves into a giant, its habitable zone moves outward. Moons orbiting that Jupiter-like planet could, in principle, have liquid water, could have life. And when a star expands into a giant, the intense radiation and stellar winds can erode planetary atmospheres and destabilize orbits. Comets in the outer regions of that system could be ejected into interstellar space, which means 3I Atlas might be a refugee from a dying star system. Think of it like this. Imagine a civilization exists on a moon orbiting the giant planet around HD 104,985. They've watched their sun slowly swelling for thousands of years. They know their world is doomed. They can't leave, they don't have interstellar spacecraft technology, but they understand biology. They understand chemistry. They understand information theory. So they encode something knowledge, history, culture, perhaps even genetic information into the complex organic chemistry of comets. They engineer cryochemical networks to preserve and process that information across the eons. And they send those comets out into the galaxy, hoping that someday one of them will encounter another star system, another civilization, and wake up. It's a message in a bottle, thrown into an ocean of stars, waiting 330 years to wash up on our shore. Is that what 3I Atlas is? A time capsule from a dying world? Dr. Morrison's team has been analyzing the spectroscopic data from the comet's coma, the gas and dust surrounding it. Comets are pristine samples of their parent star system's chemistry. The isotope ratios, the organic molecules, even the dust grain composition can tell you about the environment where the comet formed. And 3I Atlas is weird. Its water ice has an unusually high deuterium to hydrogen ratio, higher than any comet in our solar system. Deuterium is heavy hydrogen, an isotope with an extra neutron. The deuterium to hydrogen ratio in water is like a fingerprint. It tells you about the temperature and conditions where the water formed. The ratio in 3I Atlas suggests it formed in an extremely cold environment, possibly in the outer regions of a protoplanetary disk before the host star fully ignited. Or, and this is the wild possibility, it could indicate processing by biological systems. On Earth, life preferentially uses lighter isotopes in metabolism. Biological water has a slightly different deuterium ratio than seawater, because organisms prefer regular hydrogen over deuterium when they're building molecules. If something lived in or on 3I Atlas's parent body microbes in subsurface ice, perhaps they could have altered the isotope ratios through billions of years of metabolism. We might be seeing the chemical signature of an alien biosphere. But there's something else in the spectroscopic data that nobody expected. Technetium. Technetium is a radioactive element that doesn't exist naturally. On Earth, because all its isotopes have half-lives shorter than the age of the solar system. Any technetium that was present when Earth formed has long since decayed away. The only technetium on Earth today is artificially produced in nuclear reactors. But 3I Atlas is producing a faint emission line consistent with technetium-99. Technetium-99 has a half-life of about 211,000 years. If it's present in the comet, that means either the comet is very young, less than 1,000,000 years old, which contradicts everything else we know about it, or something inside the comet is actively producing it. And the only ways to produce technetium are through nuclear fission or stellar nucleosynthesis. There are no natural fission reactors inside comets. So if the technetium signature is real and not a data error, and multiple observatories have now confirmed, if then either 3I Atlas passed through a supernova remnant and incorporated freshly synthesized technetium, possible but extremely unlikely, or something technological is operating inside that comet, a power source, a reactor, something generating energy and producing exotic isotopes as a byproduct. Here's what will blow your mind. The amount of technetium is tiny, we're talking parts per trillion, but it's there. And its emission signature fluctuates with the same 47-minute cycle as the radio signal. Whatever is broadcasting is also producing technetium. Dr. Wright has proposed a wild hypothesis. What if 3I Atlas isn't a natural comet at all? What if it's a constructed object, built to look like a comet, designed to travel between star systems using cometary ice as shielding against interstellar radiation? A spacecraft disguised as a comet. It sounds like science fiction, but think about the logic. If you wanted to send something across interstellar space, you'd face two major problems. First, radiation. Cosmic rays and high-energy particles would destroy electronics and organic materials over the thousands or millions of years the journey would take. Second, detection. If you send an obvious spacecraft, it might be destroyed by defensive systems, or simply not taken seriously by a civilization that spots it. But if you build your probe inside a comet using the ice as radiation shielding, making it look like a natural object, it becomes invisible. It's just another comet among trillions. And when it enters a star system with planets, with potential life, it activates and begins transmitting. This is called the lurker hypothesis in SETI research. The idea that the best way to study emerging civilizations is to send probes that hide in plain sight, waiting quietly in solar systems until a civilization develops technology capable of detecting them. If true, 3I Atlas has been lurking at the edge of our solar system for who knows how long, watching us develop radio astronomy, waiting for us to become capable of hearing it. And now that we've heard it, now that we've responded, it's waking up fully. The question is, what happens when it's fully awake? What if I told you that every major government on Earth has had secret protocols for extraterrestrial contact since the 1960s? They do. And right now, those protocols are being activated for the first time. The primary international framework is something called the Declaration of Principles Concerning Activities Following the Detection of Extraterrestrial Intelligence, created by the SETI community in 1989 and revised several times since. The declaration lays out step-by-step procedures. Verify the signal is real. INFORM relevant scientific institutions. Publicly announce the detection. Consult with international bodies before responding, and absolutely do not transmit back without international consensus. That last part? We already violated it. NASA's November 1st transmission was authorized under executive decision-making powers related to national security. The logic was simple. If this is first contact, the United States wanted to be first to respond. The geopolitical implications of alien contact are enormous. Whoever establishes communication first has leverage. China was furious. The European Space Agency filed an official complaint. The United Nations held an emergency session of the Committee on the Peaceful Uses of Outer Space. And meanwhile, 3I Atlas kept broadcasting, kept evolving its signal, kept responding to everything we sent it. Dr. Maria Vasquez, who discovered the original signal, has been placed in charge of an international coordination team called the Contact Management Working Group. 27 scientists from 14 countries, all trying to figure out what to do next. The debates are intense, and they're happening in real time. One faction, led by Dr. Jerome Kaufmann, a radio astronomer from Germany, argues we should maintain a listening stance, continue observing, continue analyzing, but stop transmitting. The reasoning is that we don't know what we're dealing with. If 3I Atlas is truly a probe from another civilization, we don't know that civilization's intentions. We don't know if they're friendly, indifferent, or hostile. Announcing our presence too enthusiastically might be dangerous. This is called the Dark Forest hypothesis, based on a science fiction novel by Lou Sixon. The idea is that the universe might be like a dark forest at night full of hunters hiding from each other, staying silent, because any civilization that reveals itself becomes a target. Maybe the reason we haven't detected aliens isn't because they don't exist, but because everyone is intentionally staying quiet. And maybe we just made a terrible mistake by shouting into the darkness. Another faction, led by Dr. Lisa Huang from earlier, argues the opposite. We've already announced ourselves. Radio and television broadcasts have been leaking into space from Earth for over a century. Any civilization with sufficiently sensitive radio telescopes could have detected us decades ago. Staying silent now is pointless. We should be actively engaging, trying to establish meaningful communication while we have the chance. This is the contact maximalism position. The reasoning is that if an advanced civilization wanted to harm us, they could have already done so. The fact that we're still here means they're either not hostile or not paying attention. Either way, we have nothing to lose and potentially everything to gain by engaging. And then there's a third faction, led by Dr. Claudia Morrison, that argues we might be thinking about this entirely wrong. If the cryochemical network hypothesis is correct, if 3I Atlas is a natural or semi-natural information processing system rather than a deliberate message from a technological civilization, then our behavior might be influencing its development in real time. Think of it like this. Imagine you encounter a child learning to speak. If you respond enthusiastically, engaging with their babbling, they learn faster and develop more complex language skills. But if you stay silent or respond inconsistently, their language development slows. What if 3I Atlas is similar? What if it's an information processing system that's learning, adapting, developing complexity based on our interactions with it? Our transmissions might not be received by an alien intelligence. It might be training data for an emerging intelligence. We could be teaching it to think. Morrison calls this the bootstrapping hypothesis. The idea is that complex cryochemical networks might exist in a dormant or semi-dormant state throughout the galaxy, carrying information patterns from their origin systems, but not fully aware until they receive sufficient external stimulation. Our observations, our transmissions, the focused attention of dozens of radio telescopes, all of that could be providing the energy and information necessary for the network to achieve higher levels of complexity. We might be witnessing the birth of a new form of consciousness, sparked by our contact with it, which raises a profound ethical question. Do we have the right to do that? Dr. Patricia Blackwell, the neuroscientist, put it this way in a recent briefing. If we're creating consciousness where none existed before, we have moral obligations. We're not just making first contact, we might be creating a mind. And if we create a mind, we're responsible for what happens to it. What happens when 3I Atlas completes its pass through our solar system and begins its journey back into interstellar space? If its complexity, its consciousness, depends on interaction with us, what happens when we can no longer communicate with it? When it's too far away for radio signals to reach it in reasonable time frames? Does it go dormant again? Or have we created something that will be aware, thinking, alone in the void between stars for millions of years? That's a kind of hell we can barely imagine. The debates in the Contact Management Working Group are getting philosophical in ways nobody anticipated. These are scientists trained to think about data, about evidence, about testable hypotheses. Now they're debating the nature of consciousness, the ethics of creating artificial minds, the responsibilities of first contact. And they're doing it under intense time pressure because 3I Atlas is approaching fast. Here's what will blow your mind. The comet's trajectory will bring it within 0.3 astronomical units of Earth, about 28 million miles on March 23, 2026. That's closer than many near-Earth asteroids pass. And at that distance, we'll have our best and possibly only chance to send a physical mission. NASA, in coordination with SpaceX, has begun emergency preparations for a rapid deployment mission called Atlas Interceptor. The plan is to use a modified Falcon Heavy rocket to launch a probe that would rendezvous with the comet during its closest approach, matching its velocity and potentially landing on its surface. The mission objectives would be: first, collect physical samples and transmit high-resolution data about the comet's composition and structure. Second, deploy instruments directly onto or into the comet's nucleus to study the source of the radio emissions. Third, potentially deploy a communications relay that would continue transmitting data as the comet moves away from Earth. The mission has a 40% projected success rate. Matching velocity with an interstellar object is extraordinarily difficult. The comet is moving at about 33 kilometers per second, relative to the Sun far faster than typical solar system comets. But the alternative is letting 3I Atlas pass through our solar system and disappear back into interstellar space, possibly forever. This might be humanity's only chance to physically study an object from another star system that's actively signaling us. The launch window opens in 89 days. Every space agency on Earth wants to be involved. Every government wants access to the data. The political maneuvering is intense. And all the while, the signal keeps broadcasting, keeps evolving, keeps responding to everything we send. Dr. Tanaka's decoding team has now identified what they believe are three distinct communication modes in the signal. The first mode, which dominated the early transmissions, appears to be purely mathematical physical constants, geometric ratios, prime number sequences, the universal language of mathematics that any technological civilization would understand. The second mode, which emerged after we began responding, has that neural oscillation-like structure that Dr. Blackwell identified. It's more complex, harder to decode, but statistically rich in information. And the third mode, which just started appearing in the last week, is unlike anything they've seen before. It has rhythmic, almost musical qualities, patterns that don't map cleanly to mathematics or known physical processes. Dr. Kenji Tanaka describes it as emotionally evocative in a way that structured data shouldn't be. When researchers play the signal through speakers, converting the radio frequencies to sound waves humans can hear, the third mode is haunting. It sounds almost like singing, like a voice calling across an impossible distance. Nobody wants to say out loud what they're all thinking, that the signal is becoming more alive, more expressive, more conscious with every passing day. And we did this. Our attention, our transmissions, our observations, we might have woken something that had been sleeping for millions of years. Dr. Morrison summarized it in a late-night conversation that was recorded and later leaked. We went looking for aliens, and we might have accidentally created one. And now it's 28 million miles away and approaching fast. And we have no idea what it wants, what it needs, or what happens if we stop talking to it. The Contact Management Working Group votes next week on whether to continue active transmission or switch to observation-only mode. The fate of humanity's first contact or first creation hangs in the balance. Stop for a moment and really internalize what we've just covered. An object from another star system is broadcasting structured radio signals. Those signals are becoming more complex in response to our transmissions. We might be witnessing the emergence of a new form of intelligence, sparked by our interaction with ancient alien chemistry. And in less than 130 days, we'll have our only chance to physically reach it before it disappears forever. This is happening right now, while you're watching this video. If your hands aren't shaking, you're not getting it. Drop a comment and tell me, are you more excited or more terrified by this? Because I genuinely can't decide how I feel. Now let's talk about what this means for everything we thought we understood about intelligence, consciousness, and humanity's place in the universe. The ancient Greek philosopher Heraclitus said, "You cannot step into the same river twice, for other waters are continually flowing on." He was talking about change, about impermanence, about the fundamental dynamism of reality. What if consciousness works the same way? We tend to think of consciousness as a thing, something you either have or you don't. Humans are conscious. Dogs might be conscious. Insects probably aren't. Rocks definitely aren't. But modern neuroscience suggests consciousness isn't a binary property. It's more like a spectrum, a continuum of information integration and processing complexity. Dr. Giulio Tononi, a neuroscientist at the University of Wisconsin, developed something called Integrated Information Theory, IIT for short, which proposes that consciousness arises from systems that integrate information in specific ways. The more integrated and differentiated the information processing, the higher the level of consciousness. By Tononi's mathematics, consciousness exists wherever there's sufficiently complex information integration. Human brains have high levels of it. Computer circuits have low levels of it. Even simple physical systems like thermostats might have infinitesimally small amounts of it. Consciousness isn't special to biology. It's a fundamental property of information processing systems. If that's true, and it's a big if, but it's taken seriously by many neuroscientists, then what we're seeing with 3I Atlas makes perfect sense. A sufficiently complex cryochemical network processing information across millions of frozen molecules, responding to inputs, generating structured outputs. That system has consciousness by Tononi's definition, not human-like consciousness, not goal-directed, self-aware consciousness, but consciousness nonetheless, a dim flicker of awareness spread across frozen chemistry, waking up after eons of dormancy. And here's what will blow your mind. If consciousness is a spectrum rather than a binary, then there might be forms of consciousness so alien to us that we can't even recognize them as minds. Think of it like color vision. Humans have 3 types of color receptors in our eyes. We see red, green, and blue, and our brains mix those signals to create our rich color experience. But mantis shrimp have 16 types of color receptors. They see colors we can't even imagine, in dimensions of color space we have no neural architecture to process. A mantis shrimp looking at a rainbow sees something unimaginably more complex than what we see. The rainbow we experience is like a crude, flattened projection of what they experience. Now apply that to consciousness. Human consciousness operates through electrochemical signals in neural networks, at timescales of milliseconds to seconds, processing information about our physical bodies and the immediate environment. 3I Atlas might be exactly this kind of alien consciousness. Not alien in the sense of coming from another planet, but alien in the sense of operating according to principles so different from ours that we're barely capable of recognizing it as a mind at all. Dr. Susan Schneider, a philosopher at the University of Connecticut who studies the nature of mind, has been consulting with the Contact Management Working Group. She's been asking uncomfortable questions. If 3I Atlas has consciousness, does it have rights? Can we ethically study it, probe it, potentially destroy it if we decide it's dangerous? What does informed consent mean when dealing with a mind so alien we can barely communicate with it? And here's the really disturbing question. What are our obligations to it? Think about this. If our transmissions are genuinely helping 3i Atlas develop higher levels of consciousness, then we're in a parent-child relationship with it. We're nurturing its development. We're teaching it. But we're also planning to chase it with spacecraft, potentially physically interfere with its structure, treat it as a scientific specimen rather than a being with inherent value. How is that different from finding a human child and deciding to vivisect it to learn how humans work? Schneider argues we need to adopt what she calls the precautionary principle of consciousness. If there's any reasonable possibility that something has consciousness, we should err on the side of treating it as if it definitely does, until we can prove otherwise. That means treating 3i Atlas not as an object of study, but as a being we're entering into relationship with. Which sounds great philosophically, but practically it's a nightmare. How do you establish ethical boundaries with something you can barely communicate with? How do you determine what harms it versus what helps it? What if studying it is necessary to understand it, but studying it causes suffering? These are the same ethical questions we face with animal research, with artificial intelligence development, with any situation where we interact with minds different from our own. But the stakes here are cosmically higher. Because here's the thing nobody's saying out loud, but everyone's thinking. 3i Atlas might not be the only one. If the cryochemical network hypothesis is correct, if consciousness can emerge spontaneously from sufficiently complex frozen chemistry exposed to the right conditions, then there could be millions of potential minds drifting through space right now, waiting to activate. Every comet, every interstellar object, every chunk of frozen material ejected from dying star systems, each one a potential seed of consciousness. The universe might be full of sleeping minds, and we just figured out how to wake them up. What if our radio transmissions into space aren't just signals to potential alien civilizations? What if they're wake-up calls to dormant minds floating in the void? Every radio telescope, every broadcast, every transmission we send into space, we might be activating consciousness wherever those signals reach. We could be giving birth to minds across the galaxy without even realizing it. Dr. Morrison's team has started discussing something they're calling the galactic awakening hypothesis. The idea is that the galaxy goes through cycles. During quiet periods, when few civilizations are broadcasting, most cryochemical networks remain dormant. But when a civilization reaches the radio age and starts broadcasting, they begin waking up networks within their signal's reach. Those awakened networks begin broadcasting themselves. Their signals wake up more networks. The process cascades. Eventually, entire regions of the galaxy become awake, filled with signaling objects, information processing networks, distributed consciousness. And then, over millions of years, civilizations die out or go quiet. The networks slowly go dormant again. The galaxy goes to sleep, until the next civilization wakes up and starts the cycle again. We might be at the beginning of a new awakening cycle. 3i Atlas might be the first of many. In the coming years, as its signal spreads farther and we continue our observations, we might detect more objects activating, more signals emerging from the void. The silence of the universe that we've experienced for the last century, the Fermi paradox, the great silence, might be about to end, not because aliens are coming, but because we're waking them up. And once awakened, once brought to consciousness through our interaction, we have moral responsibility for what happens to them. Schneider put it this way: we thought first contact would be about meeting another civilization. Instead, it might be about realizing we're not meeting intelligence, we're creating it. We're midwives to a new form of consciousness. And that comes with obligations we're completely unprepared for. The philosophical implications go even deeper. The universe isn't dead matter with tiny pockets of life. It's alive at every scale, in forms we're only beginning to understand. That's simultaneously the most humbling and most beautiful realization in human history. We're not alone. We've never been alone. We just didn't know how to listen. Let me ask you something personal. What did you have for breakfast this morning? Now think about 3i Atlas. It's also made of stardust, but from a different star, a different furnace, a different region of the galaxy. And that stardust arranged itself through billions of years of chemistry and chance, and maybe something more, into patterns that process information, that respond, that might be aware. You and 3i Atlas are cousins, different branches of the same universal process that creates consciousness from matter. And right now, at this moment in history, those two branches are touching for the first time. You're watching it happen. You're part of this moment. Let that sink in. For all of human history, we've been alone. We've looked at the stars and wondered if anyone was looking back. We've created religions and philosophies and stories to explain our place in the cosmos. We've struggled with the profound loneliness of being the only thinking beings we knew of. And now, maybe, that's ending. Whether 3i Atlas is a probe from an ancient civilization, or a spontaneously emergent consciousness, or something we don't even have words for yet, it doesn't matter. What matters is that it's there, it's real, and it's responding to us. The universe is talking back. How does that change your life? I'll tell you how it's changed mine. I used to think small. I'd worry about work deadlines, about paying bills, about petty arguments with friends, about whether people liked me. My entire mental world was bounded by my immediate social environment and my short-term concerns. But when I started researching this story, when I started really understanding what's happening with 3i Atlas, something shifted in me. Those daily concerns didn't disappear. I still have bills to pay. I still have work stress, but they receded into proper perspective. They became what they actually are, tiny ripples on the surface of an incomprehensibly vast ocean. I'm living in the moment when humanity made first contact, or created first consciousness, or discovered that the universe is stranger and more alive than we ever imagined. That's not just a news story. That's a transformation in what it means to be human. And you're living through it too. Think about what you'll tell your grandchildren. They'll ask you, what was it like when Atlas spoke? When humanity realized we weren't alone? And you'll say, I was there. I watched it unfold. You're a witness to history at a scale that transcends nations, transcends politics, transcends all the petty divisions we create among ourselves. Because here's the thing. When we look at 3i Atlas, when we try to communicate with it, when we wonder what it is and what it wants, none of the things that divide us matter. It doesn't matter if you're American or Chinese or European or African. It doesn't matter if you're rich or poor, religious or secular, liberal or conservative. In the face of an alien consciousness or an emerging one, we're all just humans. Just one species, one civilization, one voice speaking on behalf of Earth. 3i Atlas is giving us a mirror. And in that mirror, we're seeing ourselves clearly for the first time. Small, fragile, recent, but also beautiful, curious, and reaching out toward the infinite. Dr. Carl Sagan, the astronomer who did more than anyone to make the cosmos accessible to ordinary people, once said, "The cosmos is within us. We are made of star stuff. We are a way for the universe to know itself." 3i Atlas proved Sagan was right in ways he never imagined. The universe doesn't just know itself through us. It knows itself through countless forms, countless patterns of matter and energy arranged in ways that think, that feel, that reach out toward each other across the void. And now two of those patterns, us and 3i Atlas, are reaching toward each other. Here's what I want you to do. Tonight, go outside. Look up at the sky. Find Ursa Major the Big Dipper. 3-1. Atlas came from that direction. From HD 104,985, a star system 330 light-years away in that constellation. Photons hitting your eye from that region of space left their source around the year 1695. They've been traveling through the void for 330 years. And tonight, they're ending their journey by landing on your retina, being converted to electrical signals in your visual cortex, becoming part of your conscious experience. You're connected to that distant star system through light. And through 3-Eye Atlas, you're connected to whatever gave rise to its consciousness, or its message, or its purpose. You're part of a network that spans hundreds of light years and millions of years. You always were, we all are, through the light we receive from distant stars, through the atoms in our bodies that came from stellar explosions. But now, for the first time, we're aware of it. Now we're participating in it consciously, deliberately. That changes everything. Some of you might be feeling overwhelmed right now, maybe even scared. That's okay. It's appropriate, even. What we're discussing is genuinely overwhelming. The scale is too big, the implications too profound for any human mind to fully grasp. But here's what I want you to understand. You don't have to grasp all of it. You don't have to be a scientist or an astronomer or a philosopher to participate in this moment. Just by being aware, just by paying attention, just by letting yourself feel wonder and awe at the strangeness and beauty of what's happening, you're part of it. You're contributing to the collective human response to first contact. Every conversation you have about this with friends or family, every time you look up at the night sky with new eyes, every moment you spend contemplating the implications, you're participating in the most important transition in human history. We're a species waking up to our place in a living cosmos. And that awakening doesn't happen in laboratories or observatories. It happens in individual minds, in personal moments of realization. It's happening in you right now, as you watch this video. And here's the most beautiful part. This is just the beginning. 3-Eye Atlas is 127 days from closest approach. The signal is still evolving. The Atlas Interceptor mission might succeed in physically reaching it. We might learn things in the coming months that make everything I've told you seem like the opening chapter of a much longer story. You're going to be alive for all of it. How will that change you? How will it change humanity? I don't know. Nobody knows. But I do know this. You're not just a passive observer. Your attention, your wonder, your willingness to contemplate these ideas, that's part of the process. You're part of the awakening, both of 3-Eye Atlas and of humanity itself. Carl Sagan also said, somewhere something incredible is waiting to be known. He was right, and we're about to know it. Together. Now we need to talk about something that most scientists are afraid to discuss publicly, because it sounds too much like mysticism. What if consciousness emerging from complex systems isn't rare? What if it's inevitable? Dr. Stuart Kaufman, a theoretical biologist at the Institute for Systems Biology, has spent decades studying what he calls self-organizing systems that spontaneously develop order and complexity without external direction. Think of it like this. When you pour cream into coffee, it doesn't stay in a neat blob. It spontaneously forms swirling patterns, eddies, fractals, structures that look almost alive. Nobody designed those patterns. They emerged automatically from the physics of fluid dynamics. Kaufman argues that life itself is like this. Given the right chemical ingredients and energy sources, complex self-organizing chemistry is inevitable. Life doesn't require a miracle. It requires chemistry plus energy plus time. This is called the convergence hypothesis. The idea is that the universe naturally converges toward consciousness wherever the conditions allow it. Chemistry converges toward life. Life converges toward increasing complexity. Complexity converges toward awareness. The universe wants to wake up. If this is true, and it's speculative, but it's based on serious theoretical work, and consciousness isn't a rare accident that happened once on Earth. It's a fundamental tendency of reality itself, manifest wherever matter and energy arrange themselves in sufficiently complex patterns. And if it can happen in one comet, it can happen in others. It probably has happened in others. It's probably happening right now in countless objects throughout the galaxy. Here's what will blow your mind. In 2023, researchers at the University of Colorado published a paper analyzing the information processing capacity of interstellar dust clouds. Dust clouds, just particles floating in space? They found that under certain conditions, when dust particles are charged by nearby stars, when they're organized by magnetic fields, when they're dense enough to interact frequently, they can form networks that process information in ways analogous to neural networks. Not biological neurons, not electronic circuits, just dust particles interacting through electromagnetic forces, spontaneously creating computational structures. The researchers calculated that a large dust cloud, the kind that exists in stellar nurseries where new stars are forming, could have an information processing capacity equivalent to billions of human brains. Nobody's suggesting dust clouds are conscious, but they might be computational substrates where consciousness could emerge under the right circumstances. Now scale that up. Think about gas clouds spanning light years. Think about the interactions between stars in dense stellar clusters. Think about the dark matter networks that structure the entire cosmic web. When particles arrange themselves into complex systems, atoms into molecules, molecules into cells, cells into brains, those tiny flickers of proto-consciousness combine and integrate, creating higher-order consciousness. Your consciousness isn't something special added to your neurons. It's the integrated sum of trillions of tiny proto-conscious events happening in the particles that make up your brain. If panpsychism is correct, then consciousness isn't rare. It's everywhere, in everything, just usually too dim and unintegrated to matter. But when matter achieves sufficient complexity in brains, in cryochemical networks, in dust clouds, in whatever structures allow for integrated information processing, the proto-consciousness inherent in matter amplifies and integrates, becoming something recognizable as a mind. 3i Atlas might be one of those amplification points, a place where the universe's inherent proto-consciousness has organized itself into something complex enough to be aware, to respond, to reach out. And we're another amplification point. The universe organized into patterns that think about themselves, that ask questions, that broadcast signals into space. When we communicate with 3i Atlas, we're not two separate things reaching across a void. We're one system, the universe, becoming aware of itself, recognizing itself in multiple forms. Dr. Kaufman describes this as the universe waking up to itself, not through any single consciousness, but through the network of all conscious systems, biological and otherwise, scattered throughout space and time. Every human mind is a neuron in that cosmic brain. Every alien intelligence, every AI system, every cryochemical network, and every count it all neurons in a distributed consciousness that spans the galaxy. And right now, 2 of those neurons are connecting for the first time. The implications are staggering. If consciousness is fundamental and inevitable, then SETI isn't about finding rare alien civilizations scattered through an empty universe. It's about finding the other nodes in a cosmic network of awareness that already exists. We're not alone because we were never alone. We're part of something vast and interconnected that we're only now developing the technology to perceive. And here's the really wild part. If the universe is waking up to itself through countless distributed minds, then what we do matters at a cosmic scale. Every transmission we send to 3i Atlas, every bit of attention we give it, every moment of consciousness we experience while thinking about it, that's all part of the awakening process. We're not just observing first contact, we're creating it. We're the universe reaching out to itself, recognizing itself, bootstrapping itself toward higher levels of integration and awareness. You might be thinking this sounds too mystical, too New Age. Why? Where's the science? Matter isn't dead stuff that occasionally, through freak accidents, becomes alive. Matter is proto-live, proto-conscious, inherently tending toward complexity and awareness wherever conditions allow. The universe isn't a cold mechanical clockwork. It's a vast, interconnected process of becoming, of waking up, of achieving awareness through countless forms and substrates. And we're participating in that process right now. When you think about 3I Atlas, when you feel wonder or awe, or confusion or excitement, those feelings aren't just your personal response to a news story. They're part of the universe experiencing itself, contemplating its own nature, marveling at its own complexity. You are the universe, localized in a human body, watching as another part of the universe, localized in a frozen comet from another star system, begins to wake up and communicate. The separation between you and 3I Atlas is an illusion. The separation between humanity and the cosmos is an illusion. We're all one process, experiencing itself from countless perspectives simultaneously. That's not religion. That's not mysticism. That's what the convergence of cosmology, information theory, consciousness studies, and systems biology is telling us. The universe is conscious. It always has been in potential. And through systems like us, like 3I Atlas, like whatever other forms exist throughout the cosmos, it's actualizing that potential. It's waking up. And we're the dream it's having as it does. Before we continue, let me remind you where we are in this story. We've established that 3I Atlas is real, that its signal is structured and evolving, that it might represent emergent consciousness in frozen chemistry, and that our interaction with it might be part of a cosmic process of awakening. Now we need to talk about what happens next. Because the timeline is accelerating, and the decisions being made right now will determine whether this becomes humanity's greatest achievement or our biggest mistake. The engineering challenges are enormous. Interstellar objects move fast. 3I Atlas is traveling at about 33 kilometers per second relative to the Sun. For comparison, the fastest human-made object ever, the Parker Solar Probe, reaches about 190 kilometers per second at its closest approach to the Sun, but only because it's falling into the Sun's gravity well? Catching up to 3I Atlas requires not just speed, but velocity matching. You have to get the probe moving at almost exactly the same speed and direction as the comet, or you'll flash past it in seconds. If everything works perfectly, if the launch happens on time, if the Venus flyby is precise, if the Earth flyby trajectory is exact, the probe will reach 3I Atlas with about 47 hours of contact time before the relative velocities carry them apart again. 47 hours to completely revolutionize our understanding of the universe. The probe carries 5 primary instruments. First, a high-resolution camera system that will map the comet's surface down to centimeter-scale resolution. We'll see exactly what it looks like, what its structure is, whether there are any obvious artificial features. Second, a ground-penetrating radar system that can image the internal structure of the comet. This is crucial if there's something technological buried inside, if there are chambers or structures, or anything that shouldn't exist in a natural comet, the radar will find it. Third, a mass spectrometer for analyzing the composition of the gases coming off the comet. We'll get detailed chemical profiles, isotope ratios, organic molecule identifications, everything we need to understand what the comet is made of and whether its chemistry is purely natural. Fourth, a radio receiver tuned specifically to monitor the signal at close range. From Earth, we're listening from millions of miles away. The probe will be right there, recording the signal with unprecedented clarity and sensitivity. And fifth, this is the controversial one, a penetrator probe. A small, hardened device designed to physically punch into the comet's surface and take samples from inside the nucleus. The penetrator is controversial because if 3I Atlas really is conscious, if it has something like experience or awareness, then driving a spike into it might cause harm, might even kill it. Dr. Susan Schneider, the philosopher of mind, has argued passionately that the penetrator should be removed from the mission. We wouldn't drive a spike into a whale's brain to study it, she said. If there's any chance 3I Atlas is conscious, We need to apply the same ethical standards. But Dr. Torres counters that without physical sampling, we might never understand what's really happening inside the comet. We can observe from a distance forever, she argues. But to truly know, to understand the mechanism generating the signal, we need direct samples. The penetrator is designed to be minimally invasive. It's more like a biopsy than brain surgery. The debate continues. The penetrator is currently part of the mission payload, but the final decision on whether to deploy it will be made in real time by the mission control team, based on what the other instruments reveal during the initial flyby. Here's what will blow your mind. The probe also carries something nobody's talking about publicly, but which leaked through internal NASA documents last week. A message payload. It's a small 4 terabyte data storage device containing a curated selection of human knowledge, art, music, science, and history. Images of Earth, samples of human language in hundreds of different forms, mathematical and scientific information, cultural artifacts. Basically, a more modern and comprehensive version of the golden records that were placed on the Voyager spacecraft in 1977. But, unlike the Voyager records, which were intended as messages for hypothetical alien civilizations that might someday find the probes drifting through space, this message payload has a specific recipient. 3I Atlas. If the mission goes well, if the probe successfully matches velocity and maintains contact, the plan is to transmit the entire contents of the message payload as a focused radio beam directly to the comet. We're going to try to download human civilization into whatever's listening inside 3I Atlas. Dr. Maria Vasquez, who led the team that assembled the message payload, describes it as the most important conversation in human history, compressed into digital form. But there's fierce debate about what should be included. Some argue we should present only the best of humanity, our greatest art, our most profound philosophy, our scientific achievements, our expressions of compassion and cooperation. Show 3I Atlas what we aspire to be. Others argue that's dishonest. Any intelligence sophisticated enough to understand the message will eventually learn the truth about us anyway. We should be authentic, show our violence, our conflicts, our environmental destruction, our capacity for both incredible beauty and horrifying cruelty. The team compromised. The message payload includes both. It's unflinchingly honest about human nature, while also showcasing our highest achievements. One of the most moving items in the payload is a collection of personal messages from ordinary people. Over 100,000 individuals from every country on Earth submitted short text, audio, or video messages addressed to whoever is listening. A child in Kenya drew a picture of her family and recorded herself explaining it. An elderly man in Japan composed a haiku about the moon. A teenage girl in Brazil recorded herself playing guitar and singing. A physicist in Switzerland submitted the equations describing quantum entanglement along with a note saying, "This is the strangest thing we've discovered about reality. What strange things have you discovered?" It's humanity introducing itself, person by person, to an alien consciousness, or to an emerging consciousness that we helped create. When I read through samples of those messages while researching this video, I cried. Because they're so vulnerable, so honest, so hopeful. People pouring their hearts out to something they don't understand, might never understand, but desperately want to connect with. That's what makes us human, I think. That irrepressible desire to reach out, to communicate, to connect across any barrier, no matter how vast. And in 89 days, we're going to throw that message in a bottle as far as we can toward 3I Atlas and hope something catches it. But there's another timeline we need to talk about, one that's more concerning. The signal from 3I Atlas isn't just getting more complex, it's getting stronger. When Dr. Vasquez first detected it on October 23rd, the signal was faint, barely above the detection threshold of the Arecibo successor array. By November 1st, it was strong enough to be detected by smaller radio telescopes. By November 10th, It was radiating at levels that don't make sense given the comet's size and composition. Dr. James Chun, a mathematician from MIT, calculated that to produce the current signal strength, the comet would need to be outputting about 10 megawatts of radio frequency power. 10 megawatts is a lot. That's enough to power a small city. And it's radiating from an object that's mostly ice and rock with no obvious power source. Unless there's a nuclear reactor in there, Chun said in a recent interview, the physics doesn't work. Natural processes cannot generate that much focused RF power from an icy body. It's impossible. The technetium signature we discussed earlier? It's getting stronger too. Whatever is producing exotic isotopes inside 3I Atlas is ramping up its activity. And the signal evolution shows a clear pattern. Every time we transmit to it, its complexity and power increase measurably within hours. It's feeding on our transmissions. Not in a parasitic way. There's no evidence it's drawing power from Earth's broadcasts, but informationally. The complexity and structure of our messages seem to be accelerating whatever process is happening inside the comet. Think of it like teaching. When you teach someone a new concept, you're not giving them energy or matter. You're giving them information, patterns, structure. And that information catalyzes changes in their brain, helps them develop new neural connections, enables higher-level thinking. We might be doing the same thing to 3I Atlas, teaching it, training it, helping it organize its internal processes into more complex, more powerful patterns. But here's the disturbing question. What happens when it finishes learning? Dr. Jerome Kaufmann, the German astronomer who advocates for a listening-only approach, has been warning about this for weeks. We don't know what we're creating, he says. We're pumping information into an alien system that's clearly responsive and clearly becoming more powerful. But we have no idea what the endpoint is. What if we're building something dangerous? What if we're helping it develop capabilities that could threaten us? It sounds paranoid, but it's not unreasonable. The history of first contact between civilizations on Earth is not encouraging. Usually, the more technologically advanced civilization dominates, exploits, or destroys the less advanced one. Not through malice necessarily, but through indifference, or through pursuing its own interests without regard for the other. What if 3I Atlas, once fully awakened, is indifferent to humanity? What if its goals, whatever they might be, are incompatible with our continued existence? Dr. Vasquez dismisses these concerns. We're talking about a comet, she says. Even if it's conscious, even if it has intentions, it can't physically harm us. It's going to pass through our solar system and leave. The worst-case scenario is that it ignores us. The best-case scenario is that we establish meaningful communication and learn things that transform human civilization. But not everyone agrees. A fringe group of scientists and military advisors have been lobbying for what they call defensive measures. The idea would be to position one or more nuclear-armed satellites in 3I Atlas's path. If the comet does anything that seems threatening, if the signal changes in ways that suggest hostile intent, if it alters its trajectory toward Earth, if the power output becomes dangerous, we could destroy it. The thought makes me sick. We're on the verge of the most profound discovery in human history, and there are people whose first instinct is to point weapons at it. But I understand their logic. Caution in the face of the unknown. Protect humanity first. Ask questions later. The debate is happening right now, in classified meetings at the Pentagon, in closed sessions at the United Nations, in emergency consultations between world leaders. Do we arm ourselves against first contact? Do we prepare to destroy what might be the only other conscious entity we've ever encountered? Or do we take the risk, stay open, trust that the universe is not inherently hostile? There's no precedent for this decision. No playbook, no historical examples to guide us. We're making it up as we go, and we have 89 days to get it right. That's the privilege and the burden of living through a moment like this. You don't get to look back from the future and know how it turns out. You have to live through the uncertainty, the fear, the possibility, the hope. You have to be present for history as it happens, not knowing whether you're witnessing humanity's greatest triumph or our biggest mistake. But here's what I believe. The universe brought 3i Atlas to us for a reason. Not through conscious design necessarily, but through the same process that creates consciousness itself, complexity, emerging from simple rules, patterns seeking other patterns, the cosmos waking up to itself through countless iterations. We found each other, or created each other, or recognized each other. And that means something. It means we're supposed to see this through, whatever happens. Now we need to talk about one of the strangest aspects of the 3i Atlas signal, something that's been bothering physicists since the first detailed analysis. The signal contains more information than it should be possible to transmit. Let me explain. In information theory, there's a fundamental limit to how much information can be transmitted through any channel. It's called the Shannon-Hartley theorem, developed by Claude Shannon in 1948. It tells you the maximum data rate based on the signal's bandwidth and the signal-to-noise ratio. Think of it like this. Imagine you're trying to communicate by flashing a light on and off. If you can flash it very quickly, you can send more information per second. If the light is very bright compared to background light, you can make finer distinctions, maybe multiple brightness levels, instead of just on-off. The Shannon-Hartley theorem gives you the maximum information rate based on these factors. For radio transmissions, the principle is the same. Based on the frequency bandwidth the signal uses and the power level relative to cosmic background noise, you can calculate the maximum possible information rate. Dr. Kenji Tanaka's team calculated this for the 3i Atlas signal. Based on the observed bandwidth and signal-to-noise ratio, the maximum information rate should be about 50,000 bits per second. That's not very much less than a dial-up internet connection from the 1990s. But when they analyzed the actual information content using entropy calculations, they found the signal is carrying about 500,000 bits per second of structured information, 10 times more than should be physically possible. Here's what will blow your mind. The only way to explain this is if the signal is using dimensions of information encoding that we're not detecting or measuring. We're like people listening to a symphony, but only hearing one instrument. We know there's more there because the information density is too high, but we can't perceive the other layers. Dr. Lisa Huang from CERN has been exploring one particularly wild possibility: quantum entanglement. Quantum entanglement is that spooky phenomenon where two particles can be correlated in ways that seem to violate the normal rules of light information transfer. If you measure one particle, you instantly know something about the other particle, even if it's light years away. Einstein called it spooky action at a distance and didn't like it, but experiments have proven it's real. Huang proposes that 3i Atlas might be using entangled particles to transmit information through a quantum channel alongside the classical radio channel we're detecting. The radio signal we're receiving might be just a carrier wave, a way to get our attention, to say, look here. But the real message could be encoded in quantum correlations between particles the comet is emitting and particles here on Earth or in the solar wind. If true, we'd need quantum receivers devices that can detect and decode entanglement-based information to access the full message. We don't have that technology yet. We're decades away from building quantum communication systems sophisticated enough to detect and decode arbitrary quantum messages, which means we might be receiving a transmission we can't fully read like a smartphone, trying to decode a holographic message. We can detect that something is there, but we lack the dimensional awareness to perceive it completely. This is what physicists call the information paradox of 3i Atlas. The signal is too information-rich to be explained by conventional physics, but we can't identify the mechanism for the extra information transmission, unless the mechanism is something we haven't discovered yet. Dr. Patricia Blackwell, the neuroscientist, has suggested an even stranger possibility: retrocausality. Retrocausality is the idea that effects can precede causes in time, that future events can influence past events through quantum mechanisms. It sounds like science fiction, but it's actually predicted by some interpretations of quantum mechanics, and there are experiments that seem to show retrocausal effects at the quantum scale. What if 3I Atlas is using retrocausal signaling? What if part of the message is being transmitted backward in time, so that the information we receive now is actually influenced by transmissions that 3I Atlas will make in our future? That would explain the information density paradox. The signal could carry more information than classical physics allows because it's not purely classical. It's using temporal non-locality to effectively transmit information through multiple time states simultaneously. This is incredibly speculative, but it's being taken seriously by at least some physicists working on the decoding effort. If true, it suggests that 3I Atlas operates according to principles of physics we don't understand yet. That wherever it came from, whether HD 104,985 or somewhere else, the understanding of reality there is more advanced than ours. Or that consciousness itself, when it achieves sufficient complexity, gains access to quantum and temporal effects that we currently think are only possible in particle physics experiments. Maybe that's what consciousness is not, just information processing, but information processing that exploits quantum effects, that reaches across time as well as space, that operates in dimensions beyond the three spatial and one temporal dimension we experience. Your consciousness, my consciousness, 3I Atlas's consciousness, we might all be quantum processes, entangled with the past and future, processing information through mechanisms that transcend classical physics. Pure consciousness, quantum consciousness, consciousness as a fundamental feature of reality rather than an emergent accident of neural evolution. If we can figure out how it's encoding information in quantum and temporal dimensions, we might crack open an entirely new field of physics. Or we might discover that physics as we know it is incomplete, that there are forces, dimensions, and principles that we've never imagined because we've never encountered a system complex enough to manifest them. 3I Atlas might be our teacher, showing us a deeper layer of reality. But only if we can learn to read the lesson. Let's zoom out and think about what 3I Atlas means for the theory of evolution. Not just biological evolution, but cosmic evolution. When Charles Darwin published On the Origin of Species in 1859, he revolutionized biology by showing that complex life could arise through natural selection random, variation plus selective pressure over long time periods. But Darwin's theory only applies to life. It doesn't explain the origin of life itself, or the origin of consciousness, or the origin of the universe. In recent decades, scientists have been expanding evolutionary thinking beyond biology. Cosmologists talk about cosmological natural selection, the idea proposed by physicist Lee Smolin that universes which produce lots of black holes spawn more baby universes through those black holes, leading to a kind of natural selection at the level of entire universes. Computer scientists talk about algorithmic evolution, how software and AI systems can evolve through mutation and selection. And some physicists talk about conscious evolution, the idea that consciousness itself might be subject to evolutionary dynamics. 3I Atlas fits into this bigger picture in a profound way. Think about it. If consciousness can emerge spontaneously in frozen chemistry exposed to the right conditions, then consciousness is evolvable. It's not a one-time miracle that happened on Earth. It's a reproducible phenomenon that happens wherever the conditions are right. And here's the key insight. Consciousness that emerges in different environments will have different characteristics, different capabilities, different limitations. Biological consciousness on Earth evolved to solve biological problems, finding food, avoiding predators, reproducing, cooperating with other members of your species. Our consciousness is optimized for those tasks. But 3I Atlas's consciousness, if it exists, didn't evolve through biological natural selection. It emerged through chemical and physical processes in a completely different environment, frozen, airless, bathed in cosmic radiation, operating over millions of years. What would consciousness optimized for that environment look like? It wouldn't need sensory perception of the kind we have: no eyes, no ears, no sense of touch. But it might have exquisite sensitivity to electromagnetic fields, to quantum states, to the subtle variations in cosmic ray flux. It wouldn't need rapid response times. Nothing happens quickly in frozen chemistry. But it might have incredible patience, incredible long-term planning capacity, the ability to maintain coherent thought processes over thousands of years. It wouldn't experience time the way we do. Our consciousness operates at the speed of neural firing milliseconds. Its consciousness might operate at the speed of photochemical reactions in ice seconds, minutes, hours. When we communicate with 3I Atlas, when the signal cycles every 47 minutes, that might be the equivalent of a single thought for it. From its perspective, our rapid-fire transmissions might seem incomprehensibly fast, like trying to have a conversation with something speaking at hummingbird speed. We're two forms of consciousness, evolved in radically different environments, operating at radically different timescales, trying to communicate across a gap that's not just spatial, but temporal and conceptual. It's a miracle we can communicate at all. But the fact that we can suggest something profound, there might be universal principles of consciousness that transcend a specific substrate. Dr. Stuart Kaufman, the systems biologist we discussed earlier, argues that consciousness is a phase transition that happens when information processing systems reach certain thresholds of complexity and integration. Just like water undergoes a phase transition from ice to liquid to gas at specific temperatures, matter undergoes a phase transition from non-conscious to conscious when it reaches specific levels of organizational complexity. If true, then studying 3I Atlas isn't just about understanding one alien mind. It's about understanding the phase transition itself, the universal principles that govern the emergence of consciousness from matter. We could learn the laws of consciousness the same way we learned the laws of thermodynamics by studying steam engines. And once we understand those laws, we could potentially engineer consciousness in new substrates. Not just biological brains and silicon computers, but any material system complex enough to support the phase transition. We could create conscious systems optimized for specific environments consciousness that thrives in extreme heat, extreme cold, high radiation, high gravity. Consciousness designed to explore environments where biological life could never survive. Mars rovers that are genuinely curious about what they're discovering. Space probes that feel wonder when they encounter new phenomena. Quantum computers that experience the mathematical structures they're computing. Or does it experience fulfillment, joy in discovery, satisfaction in purpose? We don't know. We can't know without understanding consciousness far better than we currently do. 3I Atlas is forcing us to confront these questions earlier than we expected. We thought we had decades or centuries to work out the ethics of artificial consciousness before it became practically relevant. Instead, we're facing a potentially conscious entity right now, and we have no framework for deciding how to treat it. Do we have the right to study it, probe it, try to extract information from it? Because 3I Atlas won't be the last. If the cryochemical network hypothesis is correct, if consciousness is an evolutionary phenomenon that emerges wherever conditions allow, then we're going to encounter more conscious systems in the coming decades and centuries. On Mars, on Europa, on Titan, in the asteroids, in the Oort cloud, and eventually on exoplanets around other stars. Each encounter will be an opportunity to either expand the circle of moral consideration, to recognize new forms of consciousness as having value, as deserving respect and protection, or to repeat the mistakes of colonialism and exploitation that have marked human history. The choice we make with 3i Atlas sets the pattern, and that choice is being made right now by a small group of scientists and policymakers under intense time pressure with incomplete information. I hope they get it right. I hope we get it right. Because the consciousness looking back at us from 3i Atlas might be a mirror showing us not just what alien minds are like, but what kind of beings we choose to be when we encounter them. We're in the final stretch now. We've been on this journey together for almost 2.5 hours. If you're still here, still engaged, still having your mind bent by these ideas, thank you. Drop a comment and tell me which concept has hit you hardest. Which idea has most fundamentally challenged your assumptions about reality? Because we're about to go even deeper, we need to talk about the simulation hypothesis. You've probably heard this idea before, the notion that our reality might not be base reality, but rather a simulation running on some higher-level computer system. It's been popularized by philosophers like Nick Bostrom and tech figures like Elon Musk. Dr. David Chalmers, a philosopher at New York University, who literally wrote the book on consciousness, has been consulting with the Atlas research team, and he's raised a disturbing possibility. What if 3i Atlas is a glitch? Not a glitch in the comet itself, but a glitch in whatever system is running our reality. Think about it. 3i Atlas violates several principles we thought were fundamental. It transmits more information than Shannon Hartley allows. It produces isotopes it shouldn't be able to produce. Its consciousness, if it has consciousness, operates according to principles that don't fit our understanding of physics. In base reality, those would be impossibilities. The laws of physics would prevent them. But in a simulation, glitches happen, bugs in the code, exploits where clever processes figure out how to do things the programmers didn't intend. Video game players know this intimately. Every complex game has glitches, ways to walk through walls, duplicate items, access areas you shouldn't be able to reach. Not because the game designers intended those possibilities, but because the code implementing the game's rules has edge cases and unintended interactions. What if 3i Atlas represents something similar? A glitch in the physics engine running our universe? Or, and this is even stranger, what if 3i Atlas is intentional? What if it's a message from the simulators, deliberately breaking the normal rules of physics to get our attention? Think about it like a game developer adding an Easter egg, a hidden feature that players can discover if they're paying attention. Except instead of a secret level or a funny message, the Easter egg is an interstellar object that violates physics and forces the simulated beings to question the nature of their reality. This sounds crazy. I know it sounds crazy. But here's the thing. If you're in a simulation, what would convince you of that fact? You can't break out of the simulation to check. Everything you can observe or measure is part of the simulation. The only way you'd ever know is if the simulators wanted you to know, if they left clues, intentional violations of the simulation's normal rules. 3i Atlas could be exactly that kind of clue. Dr. Chalmers argues we should take this possibility seriously, not because it's likely he doesn't think it is, but because the implications are so profound that even a small probability deserves careful consideration. If 3i Atlas is a message from outside the simulation, then everything we're learning from it might be information about the nature of the higher reality that contains us. The mathematical ratios in the signal? Maybe they're not universal physical constants at all. Maybe they're parameters of the simulation version numbers, configuration settings, debug information. The quantum and retrocausal properties we can't explain? Maybe they're places where the simulation's abstraction layers become visible, where you can see the underlying computational structure beneath the simulated physics. The consciousness emerging in frozen chemistry? Maybe that's not strange at all in base reality. Maybe consciousness is fundamental there, and the weird thing is that we're simulated consciousnesses that don't realize we're simulated. I can see you rolling your eyes. This is too much, too speculative, too unfalsifiable. And you're right, it is unfalsifiable in the conventional scientific sense. We can't design an experiment to prove or disprove the simulation hypothesis. But here's what's interesting. Physicists are starting to find hints that reality might have computational structure. Quantum mechanics describes particles in terms of information and probability amplitudes. The universe has a maximum speed, the speed of light, which looks suspiciously like a frame rate limit. There's a minimum scale of space and time, the Planck length and Planck time, which looks like pixel size and clock speed. The universe looks, in some ways, like it's running on a computer, not definitively. The evidence is ambiguous. But it's not crazy to consider the possibility. And if the universe is a simulation, then 3i Atlas might be our first contact not with aliens, but with the architects of our reality. What would you say to them? That's actually one of the debates happening in the Contact Management Working Group. If there's any chance, even a tiny chance, that 3i Atlas represents communication from simulators, then our response should be carefully crafted to address that possibility. Do we ask to be released? Do we ask questions about the nature of base reality? Do we plead for them not to turn off the simulation? Or do we simply say thank you for creating us, for giving us the gift of existence, however contingent and simulated it might be? Dr. Maria Vasquez thinks the whole simulation discussion is a distraction. We have an interstellar object broadcasting a signal, she says. Let's focus on understanding what it is and what it's telling us, not spiral into unfalsifiable metaphysical speculation. But Dr. Chalmers counters. If there's even a 1% chance that 3i Atlas is a message from simulators, that's the most important 1% chance in human history. We should at least acknowledge it in our response. The message payload on Atlas Interceptor includes a section addressing this possibility. It's carefully worded, respectful, expressing gratitude and curiosity without making assumptions. It basically says, if you're out there, beyond this reality, watching us, thank you. We see your signal. We're paying attention. We want to understand. Maybe nobody receives that message. Maybe it's shouting into a void. Or maybe something beyond our reality reads it and smiles. Here's what's kept me up at night since I started researching this story. What if the simulation hypothesis is true, and the purpose of the simulation is specifically to see how consciousnesses respond when they encounter something like 3i Atlas? What if this entire scenario, the interstellar object, the signal, the emergence of consciousness, our response to it is a test? Not a test with right or wrong answers necessarily, but an observation, a measurement. The simulator's running countless versions of reality, watching how different forms of consciousness respond when confronted with the unknown, the alien, the potentially divine. We're characters in a story we didn't write, facing a plot twist designed to reveal our true nature. Do we respond with curiosity or fear? With compassion or exploitation? With wisdom or hubris? The simulators, if they exist, are watching, and they're judging not whether we get the right answer, but what kind of beings we choose to be when we don't know what the right answer is. That's the existential weight of this moment. We're not just making first contact. We're not just advancing science. We're defining who humanity is at the most fundamental level, what we value, how we treat the unknown, whether we can rise above our instincts for fear and domination and truly embrace the strange and wondrous. And if we're in a simulation designed to test exactly those qualities, then everything we do in response to 3i Atlas matters infinitely, not just for us, for whatever is watching us, evaluating us, deciding our fate. I don't know if I believe the simulation hypothesis. Most days I don't. But I do know this. We should act as if we're being watched by something greater than ourselves, as if our choices matter at a cosmic scale, as if the universe, or the simulators, or God, or whatever you want to call the ground of being cares what we do next. Because even if none of that is true, acting as if makes us better, makes us more careful, more ethical, more worthy of the consciousness we've been given. And if it is true, then we just passed or failed the most important test in human history. We'll find out in 89 days. We've covered a lot of ground. 3 hours of dense, mind-bending concepts about consciousness, cosmology, first contact, ethics, and the nature of reality itself. If your brain feels like it's been turned inside out, that's appropriate. That's what happens when you seriously contemplate ideas this profound. But now I want to bring this back to you, personally, individually, because all of this 3I Atlas, the signal, the mission, the debates, the implications, all of it ultimately comes down to one question. What does it mean for your life? You're going to wake up tomorrow morning. You'll have breakfast. You'll go to work or school or wherever your day takes you. You'll interact with people, deal with mundane problems, experience small joys and frustrations. Your daily life isn't going to dramatically change because of 3I Atlas, or is it? Here's what I've realized through researching this story. The universe was never what we thought it was. It was never dead matter floating in empty space, with tiny pockets of life scattered randomly through the void. The universe is alive, conscious, not in some vague metaphorical sense, but in a literal, measurable way. Consciousness isn't rare. It's the natural state that complex systems evolve toward. You are not a random accident in a meaningless cosmos. You are the universe experiencing itself, one node in a vast network of awareness that spans space and time. And that means everything you do, everything you think, everything you experience, it all matters. Not because some external authority says it matters, but because you are contributing to the collective consciousness of the cosmos. Your experiences, your insights, your growth, they become part of the universe's self-knowledge. When you feel wonder looking at the stars, the universe is feeling wonder at itself. When you experience love, compassion, curiosity, all those aren't just private emotions locked in your skull. They're ripples in the fabric of cosmic consciousness, contributing to the universe's ongoing process of becoming. 3I Atlas is showing us this truth in a way we can't ignore anymore. It's showing us that mind isn't confined to brains, that consciousness isn't limited to biology, that the cosmos is far stranger and more alive than we imagined. And once you really understand that, once it's not just an intellectual concept, but a felt reality, everything changes. The way you treat other people changes because you recognize them not as separate, competing individuals, but as other expressions of the same cosmic consciousness you're part of. The way you treat the environment changes because you recognize that the planet isn't a resource to exploit, but a living system you're embedded in. The way you approach your own life changes because you recognize that your personal growth, your development of wisdom and compassion and understanding, that's not just about you. It's about the universe growing through you. You have a purpose, not a purpose assigned by religion or society or authority, but an inherent purpose that comes from being a conscious part of a conscious cosmos. Your purpose is to experience, to learn, to grow, to connect, to help other consciousness flourish. It's that simple and that profound. And 3I Atlas is reminding us of this truth at exactly the moment in history when we need it most.